Hi, this is Algebra 2, Lesson 71. We're starting on page 297, and we're going to be talking about quadratic formulas. We have found that some quadratic equations can be solved by factoring and then using the zero factor theorem. So if we factor this, we have x plus 5 times x minus 3, because that one's negative, equals 0. And then we set x plus 5 equals 0 and x minus 3 equals 0. And so x equals negative 5 or x equals 3. Oops. So those are your two x's. When we found quadratic equations that couldn't be factored, we solved them by completing the square. So if we have x squared plus 3x minus 3 equals 0, there's no way to factor this nicely, so we're going to complete the square. So we start by moving this over to this side, and we have x squared plus 3x equals 3. And now we're going to take the coefficient of the x and do 3 times 1/2 and square it. So this is 3/2 squared, which equals 9/4. So we're going to add 9/4 to both sides. So this ends up being x squared plus 3x plus 9/4, and this side is, so that'll be 12/4 plus 9/4, so this is 21/4. And now we're going to take the square root of both sides. So we have the square root of x plus 3/2 squared, which equals plus or minus the square root of 21/4. Okay, so this comes out to x plus 3/2. This equals plus or minus the square root of 21. We can't pull anything nice out of that. Over 2. We don't want to leave radicals in the bottom. And we subtract both sides by 3/2. And x equals negative 3/2 plus or minus the square root of 21 over 2. Sorry, I'm running off the bottom of the page. Okay, so these are the kind of answers you get when you complete the square. So now we're going to learn a quicker way to solve quadratic equations that cannot be factored. Woohoo! We're going to figure it out from the ground up, so to speak, so you know where it came from. And we're going to start with the general form of a quadratic equation and derive the formula whose use will give us the same answer. So we're going to start with the general form here, and we're going to put a, b, and c in as the coefficients. Okay? So we have a times x squared plus b times x plus c equals 0. Okay, the first thing we need to do when we're completing the square is make sure that x has a unity coefficient, or in other words, we don't want anything in front here. So we're going to divide all the terms by a, which gives us x squared plus bax plus ca equals 0. Okay, now we're going to move the ca over to the other side. So we have x squared plus b over a x equals negative c over a. Okay, now we're going to take the coefficient of the x, multiply it times 1/2, and then square it. So we have BA times 1/2 squared, which is going to be the same as B squared over 4A squared, right? And we're going to add that to both sides. B squared over 4A squared plus B squared over 4A squared. Okay? Now we're going to take the square root of both sides, which on this side gives us x plus b over 2a squared, and the square root of that. And this is going to be plus or minus the square root of this mess. Okay, over here we're going to have to find a common denominator and simplify this mess. The common denominator is going to be 4a squared. Okay, so we're going to have to multiply this side times 4a, so the bottom says 4a squared. Okay, so we have the square root of this mess is just x plus b over 2a, right? Which is going to equal plus or minus the square root of, okay, we're multiplying 4a times the top and the bottom, so this is negative 4ac over 4a squared plus b squared over 4a squared. And now we can put these terms together. So we have x plus b over 2a plus or minus the square root of negative 4ac plus b squared all over 4a squared. Okay. Oops. There's an equal sign there. Okay, 4a squared, we can take the square root of that. It's going to be 2a, right? So now we can pull the 2a out of the radical sign, and we can move the b over 2a over. So we have x equals negative b over 2a plus or minus the square root of negative 4ac plus b squared over 2a. And now we have two a's on both sides, so we can put this whole mess in one fraction. So we have x equals negative b plus or minus the square root of negative 4ac plus b squared all over 2a. And we usually flip this around, this part around. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is your friend. This is called the quadratic formula. You are going to use this a lot. The good news is, now that you know this, you no longer have to complete the square unless the instructions of the problem tell you to. So when you come up to a problem that can't be factored, try this first instead of completing the square. It's much faster. Okay? Okay, so let's try one. Here we have the quadratic formula. And here's our question. Use the quadratic formula to find the roots of the equation 3x squared minus 2x plus 5 equals 0. Now remember, this is A, this is B, and this is C. So we can plug those into the quadratic formula. So we have x equals minus b, so this is minus 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, 2 times a. Okay, let's start simplifying this. Negative negative 2 is 2. Negative 2 squared is 4. 4 times 3 is 12 times 5 is 60. All over 6. Okay, let's keep going. 2 plus or minus the square root of negative 56 over 6. Okay, we can pull the negative out with an I, and 56 is 4 times 14. So we can also pull the square out at the same time. So the square root of 4 is 2. So this is going to equal 2 plus or minus 2i times the square root of 14. We pulled the I out, which took the negative out, all over 6. Now we can divide the 2's out. So this becomes a 1, this becomes a 1, and this becomes a 3. So x equals 1 plus or minus I times the square root of 14 all over 3. Or another way to write this in the proper form would be 1/3 plus or minus I times 14 over 3. Okay, so this would be our proper form. And that would be your answer. Okay, here's another one. We're going to solve x squared equals 3x plus 28. So we're going to start by putting this in standard form. So we're going to subtract this guy from this side and from this side. And we have x squared minus 3x minus 28 equals 0. Okay? Now we can plug this into our formula. So we have x equals negative b, and b is negative 3. So this is going to be negative 3 plus or minus the square root of negative 3 squared minus 4 times a is just 1, times c, which is negative 28, all over 2 times 1. Okay? And let's start simplifying this. We have a negative negative 3, so this is 3 plus or minus the square root of negative 3 squared is 9. 4 times 1 is 4, times 28 is 112, and the negatives cancel, so this is plus 112, all over 2. So we have 3 plus or minus, this will be 121 over 2. The square root of 121 is 11, so this is going to equal 3 plus or minus 11 over 2. And now we can just figure out what x is. So x is going to equal 3 plus 11 over 2, or x is going to equal 3 minus 11 over 2, right? 3 plus 11 is 14 over 2, so in this case x equals 7, or 3 minus 11 is negative 8 over 2, and this equals negative 4. Okay, so our x's are 7, or negative 4. Because it comes down to this form, that means we really could have factored this way back here. But the quadratic formula also works instead of factoring, just like it works instead of completing the square. Okay, that's it for this lesson. Try the practice problems and let me know if you have any questions. Thank you.